Hello and welcome to the DCG's development update. We are here with the platform, the mobile, and the core teams to give you an update what happened in the past 2 weeks. I hope you're all doing well. We aim to wrap up in about an hour, and we will have a dedicated Q&A session at the end. For that, please ask your questions in the live chat below and mark the questions or use a prefix Q or question prefix so we will know that it is addressed or intended to the Q&A session. All right, without further ado, let's jump in. Let me find my windows. Sam, would you kick us off with the platform team?
Yeah, sure. So we had me, Igor, Ivan, and Lukas working on platform. And then, kind of the various parts of platform. And Lukas was working on TenderDash. Paul and Lukas were also working on, testing and strategies. And Evgeny and Odysseus in GroveDB. So let's start. We're going to start today with TenderDash. So Lukas, you want to kick us off?
Yeah, hi. So in terms of TenderDash, we are on stabilization phase. So fixing issues, bugs that we find, and adding various features that help us be more and more stable. In terms of feature, we implemented limit of concurrent gRPC connections. In another words, we will be able to limit how many messages in the same time we send from TenderDash to Drive ABCI to tune the load. For example, we want to have a priority on creating new blocks, and we don't want requests to check transactions or add transactions to the mempool to consume too much resources. So we need a way to limit that. This is why we did that. We also did some improvements to the RSTenderDash ABCI library that is used to connect as a connection between Drive and TenderDash. So basically RAS bindings for TenderDash used in Drive. These were like small issues. First one is that if you have wrong version of Proto-C tool, you get an error that you don't understand. One of the team members reported that they don't know what to do. So right now in review is a PR to just detect that and suggest. And second thing is that in some complex build scenarios, basically the code that was generating as part of the build process wasn't working correctly, so it's also fixed. In terms of other fixes to TenderDash, we did like some test fixes. We also handled some validators set update messages without any changes to validators correctly right now. And last thing is that based on TenderDash metrics, we created a public Grafana dashboard for the testnet, where you can see status and of one of our nodes. Sam will tell you more about that later on. And that's it when it comes to TenderDash. In terms of the platform, part of platform, which is Rust SDK for platform. Major change we did is reuse of DAPI connections. So previously for each request sent from the application that was using RSSDK, which created separate connection. And it wasn't too good from performance perspective. So right now we have a connection pool that is doing the job of keeping connections alive, and when they are needed, they are used. Also, a big breaking change we did. If someone is using SDK, we renamed it into Dash SDK. So that needs to be addressed by any users that we have out there. And also a small bug fix I did to fix some issue when connecting to testnet, where we use SSL certificates. Basically, there was an issue that SDK wasn't able to connect there after some changes we did. And that's more or less it on my side, but Sam also put some effort into SDK. So Sam, go ahead.
Yes. So one of the big things that we're trying to get to happen is for the mobile team to integrate the SDK into iOS and Android. And while there's a lot of work on the mobile side, there's also work on the SDK side. So one of the first things was that we were getting reports of, oh, this sub-dependency would not build on, or this dependency would not build. So I took some time to analyze all of our dependencies and figure out what we could do to make it a little bit cleaner. So I heavily reduced the dependency map that is being used, especially on validation. The RS drive part of the library actually goes down from 2.9 megabytes to 2.5 megabytes. Not much, but it's just something to note. Yeah, and then I found that a lot of the features, if you in Rust, basically you can create features on a specific library, so you don't compile the entire thing, and you can actually compile like subparts to make it more efficient or faster, or features are a great part of Rust. And we actually have a lot of features in our project, a lot of sub features, because sometimes we want only a certain part of a library. And yeah, so we probably have like maybe 50 features on Dash Platform Protocol. We have, and as an example, what is a feature? Like state transitions are a feature. So you can build the system without state transitions, actually, if you want. There's state transition validation. For example, only like you don't always need state transition validation. If, for example, you're maybe pushing to the system, but you don't need to validate what you're pushing. I don't know. There's a lot of different possibilities. So because of that, I built a small app that would check all feature combinations. And then there were a lot that were actually not working, so I fixed all of them. And the whole goal of all of this was to make mobile be able to build. So we had a lot of back and forth, and finally, the hardest problem was because of a dependency called Tower, which I'm just going to go into this because it was very time consuming and painful. Basically, Tower is using a version of index map that is very old, from a few years ago. And this version of index map basically checked the version that the what did it do? Oh, I forget what it did, but basically it wasn't able to be compiled on Android. So I patched that, and now everything is working, and we have the SDK being able to be used on mobile. And I think the mobile team will take it from there. So it's actually a really good achievement. Okay. This is just the continuation of 2 weeks ago. We had these two items as in progress, and I just wanted to, say that they're done now. I talked about them 2 weeks ago, so we can just move on. A new feature is that we can query any data on platform. And why did we introduce this? Well, we were starting to add a lot of queries for very seldomly used information. And it's sometimes, there may be too many queries, right? So the use case here was I wanted to know how many credits are on platform, like the total amount of system-wide credits. And that's actually stored in MISC data. So instead of creating a specific query for that data, now we just have a generalized query. You can just generally ask for anything inside Drive if you know where it's located. And it comes back as serialized data that then you have to deserialize it. But if you know the serialization type, it's good. And it's very powerful to be able to get any data wherever you want it. But yeah, it's not meant for things like getting back documents because the document queries are much stronger there. But for getting back like sporadic keys in different places on platform, or just actually like going through data, yeah, you can use this. Okay, let's move on. Yeah, so this is actually something that Ivan has been working on, data contract update compatibility validation. Now, Ivan sadly is sick today, so I agreed to take it to give this update for him. One thing that we noticed is that there was this section of code on data contract update compatibility that me and Ivan were both looking at, and we were not sure that it was good. So it was actually written a while back. It was actually probably the only thing left written by somebody who is no longer part of the organization. And we just needed to review it. Like, we're kind of in a review mode right now, going through code, making sure that everything there's no problem anywhere, basically. And so Ivan took upon himself to review this code and see if there was any problems, and he found these 3 issues. So basically that they're very technical, they're very technical issues, but there were problems with data contract update, and it allowed for specific attacks. And yeah, so Ivan fixed them. We can go to the next slide on solutions. He created a new library just for this validation. He introduced a lot of new compatibility rules, and I reviewed this. It's actually great work from him. So it's very nice to have this and now feel very safe about our data contract updates. One interesting note is things like min length can be changed to a bigger number, and still have the validation rule be valid, right? But you can't go to a smaller number, stuff like that. Yes. Okay, let's go on. There was also a replay attack that was found on create identity. So before we had a system where we would allow for partial usage of asset locks if a create identity should fail. And I naively thought that this would be enough, but a test showed that the replay attack was still possible on create identity. We have to understand that there's a few reasons why this probably wouldn't have been a problem. Tenderdash actually keeps all the transactions that it gets, so that when you send another transaction, if the first transaction failed, the next transaction will not basically Tenderdash will reject. However, you can do the replay attack if you do like some timing attacks, and there are other ways as well that I don't really get into. Anyways, now we have completely fixed the problem. We store state transition signable byte hashes, and we also mark it as there can only be 16 attempts to use an asset lock before we mark the total value as burned. So a user should never have this problem actually happen. They should never try to create an identity and it gets rejected. But if that were to happen, maybe by the app that they're using is on an old version, or something bad happened, then they would have 16 attempts. So probably that is more than enough. Most likely, one attempt is more than enough. So, yeah, Igor, you want to take over these other tasks?
Sure. Thank you. Okay, so this week I continued working on implementing a get identities contract keys query. It's still in progress, but we're halfway done. We made a part that returns user approve of the identities contract keys, and currently we're working on tests and the query that returns keys without the proof. The next thing we've been working on is the validation of the minimum withdrawal amount, so that core is happy, and because sometimes it's possible to withdraw too little, and it's basically will be just a dust from the perspective of the core, and the core will reject the withdrawal transactions. So we are coming up with the flexible terms that will include core fee per byte of the network, and the transaction size. Third thing was the making get status DAPI endpoint more lightweight. So originally it started about a year ago or so. We noticed that on testnet get status is super slow. Sometimes you would just wait for 5 to 8 seconds for get status to complete, and this is just to retrieve the current chain height to the wallet, which is far from optimal. And then we realized that get status is not just queries blockchain info from the core, but it also does a few other requests. 2 of them are masternode related. It's masternode status and masternode sync, and they were quite slow. So essentially, we decided to get rid of masternode related RPC queries because JS Wallet isn't using them, and mobile clients are obtaining this information by other means through the P2P. This one is in review. And the last one, get data contract history function that we are adding to RSSDK. It is currently in review as well. Thank you very much. This is it from my side.
Thank you, Igor. Paul?
Hello. Yeah, so the past 2 weeks, I have basically been working on getting load tests to work with strategy tests. So basically, like everything I had done with strategy tests before was focused on submitting transitions per block. And now, since we want to like really get like some performance testing of platform, we're focusing on like submitting lots of transactions per second. So yeah, that has introduced like a whole bunch of new complexities and issues with what I was working on before, but that's generally what I've been working on the past 2 weeks and what I'm going to continue to be working on. But we're at the point where we're starting to be able to run these performance tests, and we've discovered some things, like we had some rate limits set that we needed to lift and stuff like that. So yeah, I also created a user guide. We haven't released it yet, but we probably will release it this week. It's a user guide for how to use strategy tests. And along with that, what I want to actually show, I'm going to share my screen. Share screen. We created a new repository. Let me know if you can't see my screen. In the
We
DashPay
can.
GitHub. You can?
We can.
Okay,
We can see
great.
it.
In the DashPay GitHub, we created this new repository, platform strategy tests. So from the platform TUI, you can export the strategies that you've created, and you can import them as well based on a GitHub link. So this repository, we're going to be basically exporting our strategies that we at DCG run and posting them in here with stats and stuff. And stats with like dates that we ran the tests, so you can know like, oh, this latest upgrade improved the strategy test here or whatever. Yeah, so that's what this is, platform strategy tests. I just populated it today with a few strategies just for kind of a rough demo purpose, but I'm actually running a strategy right now, and I imported it from here, documents, 50 DashPay contact info documents per second, min fill, which means it's basically generating these DashPay contact info documents with like the minimum required data. You can change this min fill to like max fill or random fill, but for right now we're just doing min fill. So yeah, I'll just quickly show. To import this, I would click on it and then right click the raw link and copy link address. And then in the terminal user interface, well, it's running a strategy now, but you can just paste this link into here and then press the button to run the strategy. And you can see the strategy is running right now. It's broadcasting 50 transactions per second. And I'm going to pass it off to Sam now to look at the Grafana metrics of we're looking at like the real-time statistics on testnet. Sam?
I forgot to realize that I was muted. Yeah, sure, I can take over. Actually, could you just do it, Paul? Since I sent you the link. I'm having
Yeah. Sure. Okay, so you sent me the public, what is going on here? The public metrics, which only goes back, what is
1
this?
hour.
It's 1 hour? Oh,
Yeah, just scroll down.
Yeah,
See,
okay.
you can see your data. So basically, guys, at the bottom right here, he started this test, right? And you can see that we're getting about 20 transactions per second on this test. Now, we have seen higher transactions per second, so we are kind of wondering like why we're only getting 20. But we're investigating. Yeah, I mean, basically you can run your different strategies, and you can see the mempool size sometimes growing to how many transactions are basically in mempool waiting to be taken by blocks. The height of the network is increasing here. Right now we're at block 6,920 about, and the transactions per second is on the bottom one, and the 5-minute average is slowly going up. We can also see in the height, when there is no activity on the network, we don't get like the heights basically don't move much, right? Because if there are no transactions on the network, we produce a block every 3 minutes. However, when there's a lot of activity, the blocks happen much, much faster. Ideally in 5 seconds, but we are still experiencing some small issues where we're getting blocks much slower than that, like every 20, 25 seconds.
Yeah. And I think one of the things we realize why it might be 20 transactions per second now is because the documents that I'm running in this strategy are kind of big.
Yeah, the transactions per second is a very, very bad metric as well, because you could have one transaction that's 100 times or even 1,000 times stronger or more hungry, let's say, than another transaction, right? So if you get like, yeah, we should probably get another metric one day about like operations per second. But
gas per second.
or gas per second or something like that. Yes.
All right,
Anyways,
thank you.
thanks very much. Very cool.
Thank you.
So let's move on to state sync and Udi.
Yeah. Hello, guys. So quickly, let me talk about the progress on the state sync that I presented the previous spring. So the basic implementation is completed. So we are pending for review, although the PR isn't quite ready yet. So what was done during the past 2 weeks is a step towards being compatible with ABCI, basically. So the component basically that initiates a state sync for a new node. And in order to achieve this, 3 APIs on GroveDB level were implemented. The first one is basically, so just a small thing, ABCI and Drive create snapshots every, I don't know, n blocks. And so the state sync is produced when taking a specific snapshot, not from the currently open GroveDB. So in order to be able to be consistent on the data that you're going to get. And so once you open the selected snapshot, you can list all available chunks. So what does this mean is the GroveDB returns the list of the all global chunk IDs corresponding to the chunks. And so what is a global chunk ID? A global chunk ID is what needs to, what is enough to identify one specific chunk of the GroveDB. And this is basically a concatenation of two things. The hash of the full path of the tree, which is what we call prefix. So by hash, this is always 32 bytes, and the local chunk ID. The local chunk ID is a traversal instructions from the root of the subtree to the top of the chunk. And so basically, when you concatenate those two things, you can identify one specific chunk. And since Drive and NBCI have the list of available chunk IDs, they can fetch a specific chunk ID by providing they can fetch a specific chunk by providing the global chunk ID. So this is the second API implemented. Keep in mind that the purpose of this is to a new node joining the network can grab in parallel chunks from different peers. So the chunks can be fetched in parallel and not in a specific order. So once this is completed, when you have all the chunks, then the final step, as you can guess, is to reconstruct exactly the same replica of GroveDB using the fetched chunks. So what is pending along some details described above? We need to investigate if some helping metadata is required when listing all the or maybe when we describe a snapshot of database. This is already done in Drive and ABCI. Maybe we need to, for example, include the number of chunks that this snapshot is consisted. So we can know when the fetching was completed and when we know to reconstruct the database from scratch. And of course, I need to write a bunch of unit tests because we have quite a few functions that need to be covered. That's all from my part today.
And now, Afghanistan.
Hello. Today I'll present a second version of GroveDB Visualizer. This time it supports subtrees as list view, and as well as AVL trees expanded, and the data structure beneath it supports sparse data, so not fully fetched. Though in this demo I'll show fully fetched GroveDB from a platform, a local instance of platform. So let me share it. If that works, that works. So
Oh,
behold, behold, GroupDB of a local platform. And I know it looks hideous, and I'll show you in a moment that it could be also worse. But yeah, it's what happens if you load it fully. And just for the sake of the demo. So this particular example is loaded recursively from a running GroupDB. And yeah, so at first there was root tree. Here it is. And this, you can select between, as before, between different representations for keys and values, integers, strings, but here there are integers because that's how we navigate for root tree. And attention, flashbang. Sorry. So for root tree, we have identities under 32. So here it is, but I'll add later that we can jump just from the value. Cannot yet, so we'll expand it. So each subtree could be represented as AVL tree because it is an AVL tree inside. With gray links, it's left and right because it's a binary tree, and with golden, yellow links, these links are to next subtrees. So 32 goes somewhere there. Yeah, it's a subtree of identities. And for example, I take this one, I changed already the view to be this hex for keys and sometimes integers. Flashbang once again. So I think we can understand there's a revision and 192. So yeah, the lowest one. It's just zeros because I did not update this identity yet. So it's 64 bits of zeros. Yeah. Mostly, oh my God, it's so huge. Also we support references as blue links, but let's not go too deep into it because, oh my God. Yeah, and we can collapse it because if you cannot tolerate it anymore. So yeah, that was it. And future plans are include controls at least because there is no controls yet to fetch or remove data that we fetched. So that's why it's all in there. Also, query support because we don't usually have to load root and then load something from root. We want sometimes to load somewhere way below, and we need to do a query for it. So that's also a thing to work on in the following sprint. And yeah, UI improvements for sure because to tame this complexity.
I want to show something pretty cool, if you don't mind. Go to the root again. So just because we've never actually shown how the sum trees work, right?
Don't. So yeah, I disabled sum trees because it was huge.
No, but just the sum value is correct, right?
Yeah, some value is fetched, but the actual sum tree is somewhere there. But yeah, it should be. Let me. Yeah, 96, but I removed all the data from it because.
Yeah. We don't need to go that far deep there. But what I wanted to point out is inside our state, right, we have two trees that are the sum trees. One of them is the identity balances. I think that's 96, or which one?
Yes.
Yeah, 96.
Balances yeah. Oh no.
Balance.
Oh, this yeah, balance is 96.
And we have go back for 48. What's 48 again?
Pools.
Pools, yeah. So pools is where we get the processing fees distributed, right? So basically, the first number that we see here is the current fees that are going to Evo node operators. And the second one is the bigger number is the total balance of all identities in the system. And yeah, so the first one is like the money in progress going to Evo node operators. And actually, if you added these two values together and you went to the MISC tree, go to the MISC tree. Maybe you have
MISC.
it loaded. 112.
112. Let me expand. Here we go. Oh my, oh my. This one? Not. Yes, this. Is it also integer? Yes, 68. What is it? Some integers? Integers, I don't know what it is.
That's a tree. Oh, did you not load the sub elements?
There is only one item in the subtree.
Oh yeah. The item in the subtree is basically it's put it as an integer, not as bytes.
I have only bytes, string, or hex.
Oh no, I'm confused then. What's this? What about the first one? 68?
It's a 1 byte.
Yeah.
A key in the subtree.
Oh,
Only one.
interesting. I
Let
thought
me
it
go
was.
back. So the path is 112, and it contains one key.
Yes. That is a variant.
Seems
So
like a feature request.
we have a feature request right now. Yeah, we need to support variants as well. But basically, this number that's represented here is actually the sum of the two sum trees on the left side. And 2 weeks from now, we can show it. But it's very, very cool, basically. So like on every single block, we validate that the amount of credits that was put into the system is equal to the total amount of the pools and the balances. So no inflationary bugs.
Oh my.
Yeah.
Well, thanks for the comments, and
Yeah, I
that's
just
it for
wanted
me.
to show it. It's so cool to see it visually for the first time ever. This is wonderful.
Thank you.
Ready.
Actually, before we finish with platform team, I did want to add one thing. I've currently I didn't make a slide for it, but some people were asking recently what has happened to Mastnode voting, and where's that? Have you finished yet? I just wanted to let people know that I have been working on that for the last 3 days, so hopefully it will be done in 2 weeks from now. I just didn't want to put like, in progress, because we had so much already to show.
Thank you very much. Shall we continue with the core team?
Sounds good. Feel free to move on to the next slide. So I think it was right about 2 weeks ago, we released 20.1.1. I think I reported on it last presentation, but 20.1.1 did get released. That fixes a deadlock that causes can potentially cause Mastnode to get banned. It's very rare, but it does happen. So we saw it especially on our testnet environment. So very good to finally get that fixed, and we released that version to include that fix. Otherwise, moving forward well with version 21 development work. It's always hard to show because they're very just long-standing tasks and a lot of backports. If you compare the backports in the bottom right to previous week, we did make, or previous sprint review, we did make significant progress. I think close to around 100 backports were merged in the last 2 weeks, so that's always good to see. But yeah, making solid progress on V21 development, but nothing super interesting to really show or report there. We can move on to the next slide, just briefly showing we're up to about 145 Evo nodes now. There's 2 more than last sprint review, I think, something like that. And 20.1.1 is getting solid adoption. No issues have been reported, around 24%. 20.1 is closer to about 39%. So overall, good to see there, decent adoption rate. And if we go to the next slide, we can take a look at the pull requests that have been merged in the last 2 weeks. So a decently solid number of PRs. I did do some work on actually implementing read-write locks in our threading stuff. For some reason, this is something that Bitcoin never really prioritized. There isn't a ton of stuff in Bitcoin's code base that is reader heavy, writer few. But we have a couple of things that are very reader heavy. We have a couple of things like sport caches and stuff like that that maybe get written to every month, if that, but get read from, thousands of times maybe. So we implemented some reader writer locks, and I'm investigating some better ways to minimize mutex contention. But yeah, you can take a look through here. Basically, a lot of backports. There's some other refactoring and what I just talked about. But in the release of 20.1.1, we did actually, for the first time, the final SHA-256 sum that gets that you can use to validate all of the other binaries. That is now signed by multiple people within the team. So we've always had Gideon or Guix as reproducible builds, but now even just by downloading the SHA-256 sum and using that, you can tell that at the very least, me, Eugene, and Constantine all agree that these binaries are the proper binaries for this version. So that is a pretty solid benefit. Took a little bit of refactoring to our release process and how Guix functions in order to make that happen. But yeah, my signature is still on there, so no processes or automated stuff should break from that. But it's a nice little improvement that people can see. Multiple of our developers have signed off on that SHA-256 sum. As always, you could look at the Guix SIGs repo and see all of the people that have built for a specific version, but that's kind of a little bit more effort than most users are going to do. So yeah, all right, I think that's all that I wanted to talk about. We can move on to mobile.
Thank you very much. Brian?
All right, can move on to the first slide there. So another fairly aggressive sprint. I'd say we had a lot of stuff that we planned. So there's the Rust libraries. For clarification, those that aren't clear on exactly how these are broken out, at least for Android, most of their development when they're upgrading to the SDK or a new version is done on a desktop, like Windows, Linux, or whatnot, and that's built from a Java library basically, and then that's later ported to an Android SDK, which is essentially the same code, but it's obviously just for Android devices. So that was the continued work that goes on. They created examples in Java, and then a one-time task to create the Android SDK. CoinJoin, we did some UI work there for our next release coming up. That's going to be released probably today to the alpha users. And then after that's been out in the world for a little bit on testnet, we'll move on to our some mainnet testing of the CoinJoin feature. just some small updates for logging on our syncing process to Dash Wallet. A new feature, Zen Ledger, was implemented. It's a fairly minor feature, but it's nice. A nice way to kind of get you introduced to the Zen Ledger platform. It's a tax platform, and helps you deal with all your capital gains calculations across all your different wallets. And you can get a discount, 15% discount, if you sign up through the Dash wallet. So you can have a look at that feature. It's on 8.1 that was released recently. And then continue to work on the Maya integration. Yep, iOS. So this is just all the backend work and the macro work for those Rust libraries I just talked about. And so that work continues. We had some new Apple Store guidelines that we had to deal with in Dash Wallet, so that was done. And the same Zen Ledger feature that I spoke about in Android is also coming in 8.1 for iOS. That has been in the Apple Store for, I think, about a week now. Stuck in review. We're going back and forth with them again. So I don't have a time frame for when that's going to be released yet. And then a lot of work on CoinJoin for iOS too. Yeah, so that is it for mobile.
Thank you very much. So let's move on to the Q&A. The first question is from Ryan. Has DCG ever, oh no, we already answered. Let me just read it out loud. Has DCG ever explained explicitly the plan with SDK? My understanding is that we spend a lot of resources building separate Objective-C/Swift, Java/Kotlin, and JavaScript SDKs. Is the plan now to scrap these and replace them with one Rust SDK with the wrappers for various platforms? And then can you please explain it in the Q&A section?
Sure,
Sam?
I'll take that. Yeah, I'll take that. You can hear me, right?
Yes.
The answer is not very straightforward. And probably over a long period of time, yes, eventually we will have one Rust SDK and we will have multiple bindings on top of them. But in reality, we have certain features present in various SDKs, and it would be a lot of work to complete this transition to one Rust SDK with bindings. So in the effort of, well, getting stuff out, we are making the trade-offs that we need to do to keep the code that we had written in the past. Yeah, basically. Ryan, let me know if that explains. About the rationale, we have to think kind of about history, right? So we had an iOS SDK, we had an Android SDK, and we had a JavaScript SDK, right? We had those three. They were developed without a common ground. And this was because if we would have had to back in 2018, we would have had to use, we would have had to write it probably in C++ or in some low-level language, and writing such an SDK in C++. It's pretty daunting. Nowadays, Rust has come along, and we can write it in Rust, and Rust can be easily ported to other languages. Easily, maybe a little bit. Not ported. I mean, we can create bindings for other languages. Easy is maybe an overstatement. it's not always that easy, but it's easier than it used to be.
Thank you. By the way, your camera is off.
Oh, sorry.
So next question is, at what point will Evo be far enough out that non-platform devs, for example, core, won't be required to help out anymore? When that hits, can you mention it publicly?
It's not so much about being far enough along. It's more about us having more hires. And that will come, well, maybe a combination of factors, but that will come when we have completed more additional hires.
Thank you. Next question. Can you let me know when we are past don't bother the devs and onto where we can do significant documentation and content creation about what Evo is and how it works?
Yes. Can I just leave it at that? Maybe, yeah, I will let you know for sure. But it won't be in the next month or two, that's for sure.
Thank you very much. Next question. For the platform testing, could you give a bit more context for big documents? Is that like an internet news article size, or what do you mean? I think that refers.
Not that big.
Oh, okay.
How big would you say? Just a few, maybe like a paragraph big or 2 paragraphs big.
Yeah, it's like a pretty big, it's a pretty big paragraph with just random numbers and letters, but there's also a unique index with 3 properties and a non-unique index as well.
Yeah.
So I'm not exactly sure if there's 2 indexes. Can you explain how that affects it?
Oh yeah, the more indexes you have, the more extra data is inserted into the system. That's why app developers really need to make sure that they create only the indexes that they need for their dApps. And so every single index you have inserts data every single time you insert a document. So, but the indexes allow you to query the data in the decentralized system. So it's a trade-off. You want the indexes, just not too many.
All right. Thanks for being here, participating, giving us feedback and questions. That's it for today, as I see no further questions. Thanks again, and see you in 2 weeks.
Thanks, guys.
Bye-bye.